The James Webb Space Telescope has once again proven to be humanity's most powerful window into the cosmos. As a technological marvel of our age, Webb was designed not only to observe distant galaxies but also to probe the atmospheres of exoplanets with precision unmatched by any previous telescope. Equipped with cutting-edge infrared capabilities and incredibly sensitive spectroscopic instruments, the telescope has now detected what may be one of the most important planetary discoveries to date. A highly habitable super-Earth just 40 light-years away in the TRAPPIST-1 system. This newly observed planet is larger than Earth, yet smaller than Neptune, placing it within the planetary classification of super-Earths. Its size and composition suggest that it is rocky like our planet, not gaseous like Jupiter or Saturn. But what truly sets this world apart is its location within the habitable zone of its parent star. A region where conditions are just right for the presence of liquid water on the surface. And where there's water, there may be life. This discovery is nothing short of monumental. It pushes us to re-examine some of the most profound questions ever asked. Could life exist beyond Earth? If so, what might it look like? And are we truly alone in the universe? The answers may lie on this distant world. So, what exactly makes a super-Earth so special? Super-Earths occupy a unique niche in planetary science. They are typically rocky worlds with masses up to 10 times that of Earth, possessing stronger gravity and thicker atmospheres. These characteristics could make them ideal candidates for habitability. A denser atmosphere might protect potential life from harmful cosmic radiation, while higher gravity could help stabilize climate systems over geological timescales. These are not just theoretical possibilities. These are the very features that make this newly discovered world a prime candidate for life. Using its powerful array of sensors, the James Webb Telescope detected water vapor, methane, carbon dioxide, and traces of oxygen in the atmosphere of this super-Earth. These are not just random chemicals, they are key ingredients for life as we know it. The presence of these gases in specific ratios has triggered immense excitement among the scientific community. On Earth, similar chemical combinations are typically associated with biological activity. Of course, there are alternative explanations. Geological processes can also produce methane or carbon dioxide. However, the balance and ratios observed here are unusual, potentially indicative of processes that mirror those found in Earth's biosphere. It's a cosmic clue, a tantalizing whisper from across the galaxy suggesting that we may not be alone. This super-Earth orbits TRAPPIST-1, an ultra-cool red dwarf star that has fascinated scientists for years. The system is known to host 7 rocky planets, 3 of which fall within the habitable zone. But this particular planet, now identified as the most Earth-like in terms of its atmospheric composition, has become the crown jewel of the system. Its star is smaller and cooler than our Sun, providing a relatively calm and stable environment. The lower radiation levels compared to more volatile stars help preserve any delicate chemical balance that could support life. However, there's a twist. Due to its close orbit around its star, the planet is likely tidally locked, meaning one side always faces the star, basking in eternal daylight, while the other remains in perpetual darkness. This could present major challenges for habitability. The bright side could be scorching, the dark side freezing. But here's where the planet's dense atmosphere might come into play. It could act as a thermal blanket, distributing heat from the day side to the night side, creating a more balanced, temperate environment across its surface. Scientists believe that along the terminator line, the thin region where day transitions into night, conditions might be just right for life to exist. Here, temperatures could be moderate, water could remain liquid, and microbial life, or something more advanced, might thrive. This boundary between light and darkness is more than a scientific curiosity. It might be a lifeline in the harsh conditions of space. The discovery of such a promising candidate for life wouldn't have been possible without the groundbreaking capabilities of the James Webb Telescope. It can analyze the faintest signals from distant stars and planets, peeling back layers of information embedded in the light that reaches us from across the galaxy. By using infrared spectroscopy, Webb can determine the chemical composition of a planet's atmosphere with remarkable precision. And this is just the beginning. Future missions and telescopes will build upon this discovery, providing even more detailed information. Scientists on Earth are already enhancing the data using machine learning algorithms, allowing for more refined interpretations of the planet's atmospheric layers, potential surface conditions, and climate dynamics. This discovery also raises important philosophical and ethical questions. If we find definitive signs of life, or even intelligent life, how should we respond? Some argue that reaching out to extraterrestrial civilizations could lead to transformative breakthroughs for humanity. Others, including renowned physicists like Michio Kaku, urge caution. Making contact could reveal our location to civilizations with unknown intentions or advanced technologies far beyond ours. It's a debate that has suddenly become more urgent, no longer confined to science fiction. Still, the allure of exploration continues to drive us forward. Even though this super-Earth lies 40 light-years away, a distance far beyond the reach of any current spacecraft, new technologies are already in development to help bridge this vast gulf. Concepts like light sails powered by lasers or nuclear propulsion systems could one day allow us to send tiny, high-speed probes across interstellar distances. Projects such as the Breakthrough Starshot initiative aim to do just that. These probes, no larger than a smartphone, could travel at a fraction of the speed of light, reaching nearby star systems within a few decades. They might be our first interstellar ambassadors, carrying humanity's curiosity into the unknown and sending back close-up data of alien worlds. Meanwhile, here on Earth, public interest in space exploration is reaching new heights. Governments and private institutions alike are investing heavily in missions to study exoplanets. The construction of next-generation ground-based telescopes, such as the Extremely Large Telescope, ELT, and the Giant Magellan Telescope, GMT, will provide even more powerful tools for examining these distant planets. But beyond the data and technology, perhaps the most thrilling part of this discovery is the imagination it ignites. What might life look like on this world? Given the planet's high gravity, dense atmosphere, and possible oceans, life forms could evolve in radically different ways. Microbial life may dominate, or perhaps entire ecosystems have taken shape, shaped by the extreme environments of tidal locking and limited sunlight. Life in the oceans could rely on chemosynthesis, just as some deep-sea organisms on Earth do, thriving without sunlight. And if intelligent life does exist there, it might perceive time, energy, and space in completely different ways. Civilizations could have risen and fallen without us ever knowing, or they might be watching the stars as we are, wondering if they're alone. As the evidence for habitability grows stronger, the race is on to confirm the next steps. Scientists are now focused on identifying biosignatures, distinct chemical patterns that could indicate living processes. They are analyzing fluctuations in atmospheric gases, searching for seasonal or unexpected variations that mirror the dynamic biosphere we see on Earth. These subtle clues could be the first signs of biological cycles on a distant world. And so, the discovery of this super-Earth is not just a milestone, it is a launchpad for humanity's next great journey. It calls on us to expand our understanding, push the boundaries of technology, and confront the deeper questions of existence. What is life? Why does it arise? Are we a cosmic fluke, or part of a greater network of intelligent beings scattered across the stars? As we gather more data, launch more missions, and peer deeper into the universe, the answers may finally come into view. The discovery of this planet is a turning point, not just for science but for the human story. We at Discovery at 2.0 invite you to be part of this incredible adventure. If this story inspired you, if it sparked wonder, curiosity, and the urge to know more, don't forget to like this video, subscribe to our channel, and hit the notification bell so you won't miss any of our upcoming explorations into space and science. Thank you for watching. And until next time, keep looking up, because the next great discovery might be just beyond the stars.